Hello, welcome everyone. Welcome back to my channel. Well, in last class we have done frustum of cones, and in this lecture we are doing the worksheet on frustum of cones. I guess you have already gone through the basics, and now we will be doing questions all together. So when you see a question on the screen, try to solve it first. Just pause this video, try to solve it, and if you can't, then you can take help, or if you have done also, you can see and check your answer. Well, if you need classes, the live online classes for group or one-on-one for GCSEs, they are pretty much affordable. You can just email us at exactadmin@gmail.com for any subject, and I have tutors for all subjects, so they will help you and assist you. And we are also running the crash courses that have already started from 1st of January, so you can enroll for that as well. Or if you're looking for classes from year 1 to year 13, even for 11 plus you're looking for, or for GCSEs, or for any entrance exam, or for like Olympiad, we provide classes for all these. So to book a free demo, just email us at exactadmin@gmail.com, and to avail this worksheet for free, obviously it's free, so you can access it on exactadmin.com. So let me start with this question. It says find the area of the following frustum is in this frustum of cone, like if this frustum of cone is made from a cone of height 15 centimeters and slant height of 25 centimeters. Okay, so you can clearly see here that the question is all about finding the total surface area. When I was going through the theory, I have explained it as well, that the surface area is the sum of all the areas of the surfaces that you can see. And for a frustum, we have three surfaces: this one, and this one. So we have to calculate the area of each. The upper one and the bottom one are basically the circles, so we have to calculate the area of the circles. So this is going to be 12 squared pi r squared. So 12 squared pi would be the area for the upper part. Area of the lower part is 20 squared pi plus. Now we have to calculate the curved surface area of this one. We can't calculate directly as we don't have any formula, but we can calculate the curved surface area of the cone of this frustum is a part of, and it's given that that cone has a height of 15 centimeter and a slant height of 25 centimeters. So I can calculate the curved surface area of that would be 2 pi RL. Pi RL. So pi R is 20 and L is 25 minus. Now I have to subtract this part. If I'll subtract this part from this cone, obviously this frustum I'll get. So curved part, the area of the curved surface of this smaller cone is, radius is already given, which is here 12 centimeters. So this is 12, and slant height is clearly, because the total slant height is 25, this is 10, so this slant height would be 25 minus 10, which is 15. So this will be pi r L. If we solve, we'll get this. This will give us 144 pi. This will be plus 400 pi. This would be plus 500 pi. And this would be 320 pi. If we solve, we'll get 724 pi. And if I'll put the value of pi, I'll get 2273.36 centimeters squared. Obviously, surface area is always the squared, so this will be centimeter squared. Moving on to the next question. It says find the area of the following frustum if this frustum is made up of a cone for height 8 centimeters and slant height 10 centimeters. So we have to calculate the total surface area. It's exactly the same question. So we have to calculate the area of upper part, the curved part, and the lower part. So upper part is pi r squared. So pi times 3 squared plus pi times 6 squared. And same for the curved part, I'll calculate the total area of this cone, the curved part of the cone, which is pi r l. So total slant height of this cone is given as 10 centimeters. That means this whole is 10 centimeters. So pi times 6 times L, which is 10, minus. After calculating the whole curved part of the bigger cone, we have to subtract the curved part of the smaller cone. So, which is pi times 3. Obviously, for the smaller cone, the radius is 3 and the slant height is 5 because this total is 10. This is 5. So, this remaining is definitely 10 minus 5, which is 5. This will be 9 pi. This is 36 pi. This is 60 pi and minus 15 pi. This is equals to 90 pi. And now on putting the value of pi, we'll get the answer as 8282.6 centimeters squared. Moving on to the next question. Question 3 says, find the total surface area of the following frustum if the slant height of the cone was 13 centimeters. Still, we have to do the same thing. That means calculating the area of all the three surfaces. But here you can clearly see no radius is given. So we have to use the fact which I already explained in the last class, that the bigger cone of which this frustum is a part, so this whole bigger cone, this one, and the smaller cone that you have cut down to make it a frustum, that means this one, they both are similar figures. So they both are similar cones. So I can easily calculate their missing radius because the similar figures have the same angles but their corresponding sides are in ratio. So which means this whole length is given as 13 centimeters. It's given slant height of the cone is 13. So this whole length is 13 centimeters. And for the smaller part, if this is 10, so obviously the smaller part will be 13 minus 10, which is 3. This radius is 5, so this would be x. Now, dividing the corresponding sides, 13 over 3. So slant height of the bigger divided by the slant height of the smaller cone. Similarly, is equals to, because they bear the same ratio, same proportion. That means if one side is double the other side, every corresponding side would be double. So 13 over 3 should be equals to 5 over x. Now radius and radius I'm dividing. So x is 5 times 3. So we got this as 1.15. So we have calculated this radius as 1.15. Now the rest of the part is exactly how we did the previous two questions. That means calculating the area of each surface. So calculating the area of the top one first, which is pi r squared, which is pi times 1.15 whole squared, plus the bottom one is pi times 5 squared, plus we have to calculate the curved part of the bigger cone, which is pi r l, that is pi r is 5 and l is 13, minus we have to calculate the curved part of the smaller cone, which is pi. Radius we have calculated as 1.15 times L, which is 3. On solving this, we'll get, so final answer is 275.9118. So 275.91 centimeters squared is the final answer. Now let me move on to the next question. Now see this question number 4. Find the total surface area of the following frustum if the slant height of the cone was 26 centimeters. This question is exactly like the question number 3, where we have to calculate the radius, and the rest of the parts are exactly the same. As I just explained that the smaller cone and this bigger cone are similar. So this slant height, which is given as 26, so this part would be 26 minus 14, which is 12. So 26 divided by 12 is equals to, that means similar figures are, when you divide the corresponding sides, they are in same proportion. And now 10 divided by x. So this is 10, and let's say the radius of the smaller cone be x. From here, I'll calculate x as 12 times 10 over 26. The radius will be approximately 4.6 centimeters. Okay, since we have calculated the value of x, that is the radius, now it's easy for us to calculate the area of this frustum. Upper part would be pi r squared, which is pi times 4.6 whole squared, plus area of the bottom one, which is pi times 10 squared, plus curved part of this frustum, which is definitely, we have to calculate curved part of the bigger cone, which is pi r L. So for the bigger one, slant height is 26 centimeters and radius is 10. So the bigger cone has a curved part as pi r L. So pi times r is 10 and L is 26. Subtract the smaller cone curved part, which is pi r L. So for this one, we have calculated the radius as 4.6 and slant height of this one is 12 centimeters. So pi times 12 times 4.6, which will give us the answer as, it's 1023.5 centimeters squared. This is our final answer. Moving on to the question number 5. Calculate the volume of the following frustum if it's a part of a cone with height 24 centimeters. Well, in the theory, I explained that if you want to calculate the volume of a frustum, we have to calculate the volume of the bigger cone and subtract the volume of the smaller cone. So obviously, this is the bigger cone. I have to calculate the volume, and then I have to subtract the volume of this smaller cone. Remaining would be the frustum. So this will be, the bigger cone will be 1 over 3 pi r squared h. This is how you can calculate the volume of any cone. This is the formula. So for the bigger one, when I'm drawing the bigger one, height, the vertical height is already given as 24, and I should know r. So how can we calculate r? R we can calculate by the same thing, that the bigger cone and the smaller cone are proportional because they are similar figures. So the height of the bigger cone over height of smaller cone is equals to radius of bigger cone over radius of a smaller cone. From here, x is equals to 6 times 7 over 24. That will give you 1.75. So we have calculated the radius of smaller cone as 1.75. So this would be 1.75. Now we can easily calculate the volume of the bigger cone and subtract the volume of smaller cone. Volume of bigger cone is 1 over 3 pi r squared, which is 7 squared, over times h, which is 24, minus volume of smaller cone. This is smaller cone. Definitely the radius of smaller cone is 1.75 that we have calculated. And vertical height is what? The total vertical height is 24. That means this whole is 24. Whereas the height of the frustum is 6. So this would be 24 minus 6, that is 18. So the volume of smaller cone is 1 over 3 pi r squared, which is 1.75 whole squared, times h, that is 18. On solving, we'll get the answer as, so final answer is 1173.18 centimeter squared. This is the answer. Moving on to the next question. It's almost same question. Calculate the volume of the frustum if it's a part of the cone with height 24 centimeters. So same. First, we have to calculate this radius, and this can be calculated using the similarity that the bigger cone and the smaller cone are similar. So the bigger cone I'm drawing and the smaller cone. Radius of bigger cone is 18. Let's say this be x. Vertical height of the bigger cone is given as 24, and the smaller one is, if this whole is 24, so this part would be 24 minus 16, which is 8. So height of smaller would be 8. Now I have to divide. So height of bigger cone over height of smaller cone equals radius of bigger over radius of smaller. Well, I can clearly see that the bigger one is 3 times the smaller, so which means I can easily calculate that radius be x, but still if we solve, it will be 18 times 8 over 24, which is 6 centimeters. So we have calculated this as 6 centimeters. Now we have to calculate the volume of the bigger cone and the volume of smaller cone. Volume of bigger cone is 1 over 3 pi times r squared, which is 18 squared, times h, that is 24. And for smaller cone, we just calculated it as 6 centimeters. So this would be 1 over 3 pi times r squared, which is 6 squared, times h, that is 8. Now we have to subtract the volume of the bigger and the smaller one, and it will give me, so the final answer is 7837.44 centimeter cubed. Up there I by mistake wrote centimeter squared. This is cubed. Now question number 7. Calculate the volume of the frustum if the volume of the larger cone is 1500 pi. See, this is the bigger cone. The volume of this one is given as 1500 pi. And nothing is mentioned. I mean, though here it's given, the radius is given, the other radius, but that's not gonna help, right? So there is one more thing that we have to keep in mind, is that the smaller cone and the bigger cone are similar. So this bigger cone is 1500. So the smaller cone, we have studied one thing which is called volume scale factor. So if two figures are similar and the volume of bigger one or the smaller one is given, by multiplying or dividing it by the volume scale factor, we can calculate the volume of other figure. We have the volume of bigger one, we just have to calculate the scale factor. How can we calculate the scale factor? And for that, these radius are given, because there is a relationship between, there are two ways by which you can calculate volume scale factor. Volume of bigger cone divided by volume of smaller cone, or volume of one figure divided by volume of another figure will give you the volume scale factor. If you divide the volume of each of this figure, you will get, suppose the volume of bigger is x and volume of smaller be y, so x divided by y will give you volume scale factor. But unfortunately, they haven't mentioned anything directly, and using this formula we cannot get the volume scale factor, because ultimately we have to calculate the smaller one, the volume of smaller one. So now we'll use the another formula which says that if you have the length scale factor, so the square of length scale factor is called area scale factor. Let's say L be the length scale factor. So if I square the length scale factor, I'll get area scale factor. And if I cube the length scale factor, I'll get volume scale factor. So for that, they have given the corresponding radius so that we can calculate the volume scale factor. So when you divide the corresponding sides, you will get the length scale factor. So length scale factor is radius of the bigger cone over radius of smaller cone, which is 2.5. So if 2.5 is the length scale factor, I need to cube it, which will give me 15.625. So L cube, or cube of 2.5, will give me 15.625. 15.625 is your volume scale factor. You have 5001500 pi as volume of bigger cone. So volume of bigger cone over volume, let's say volume of the smaller cone be V, and this is equals to 15.625. So the smaller cone is 1500 pi over 15.625. That will give you answer as 96 pi. So now I know that the volume of bigger cone is 1500 pi and volume of smaller cone is 96 pi. So we know that the volume of frustum is what? You just need to subtract both, volume of bigger cone minus volume of smaller cone. So I'm just subtracting volume of bigger cone minus volume of smaller cone. That will give you 1404 pi as the answer. Now, a conical flask is filled with liquid up to a certain height. If the radius of the cone is 28% of the slant height, then calculate the volume of the flask which is unfilled. So first thing is, they have mentioned the relationship between the radius and the slant height. So a conical flask is filled with liquid up to certain height. This is the certain height up to which it has filled, this one here. Now it says that if the radius of the cone is 28% of the slant height of the cone, that means obviously this bigger cone they are talking about. So if the radius is 28% of 50, so 28% of 50 is what? 40. 50 times 28 over 100. This is how we can calculate. That will give you 14. So 14 is the radius of this cone. So we got 14 centimeters. After calculating the radius, we have to calculate the volume of flask which is unfilled. I can clearly see this is actually a frustum. And if I want to calculate, I just need to calculate volume of this bigger cone and volume of this cone which is filled. It's easy for me now because I do have the length scale factor. I can calculate the height. So I have this radius. First, I need to calculate the vertical height for the bigger cone. I do have a slant height, I do have a radius, and we know it forms a right angle triangle. A cone is what? When you rotate a right angle triangle about its one side, about the side which is basically the leg, then you will get a right circular cone. So this is basically a right triangle. To calculate the height, I have to apply Pythagoras theorem, which will give me 50 squared. See, hypotenuse, square of hypotenuse is always equals to square of other two sides. And how would we know that which is hypotenuse? Hypotenuse is always opposite to the right angle. This is right angle obviously. So the side opposite to right angle is always hypotenuse. So 50 squared is equals to 14 squared plus, let's say this be h squared. So h squared is 50 squared minus 14 squared. So this will give me, this is equals to, h squared is 2304, and on taking root, I'll get h as 48 centimeters. So height is 48 centimeters. We have calculated the height of the bigger cone. Now we have to calculate the height of the smaller cone using similarity. We do have the slant height, the ratio of slant height. Now we can easily calculate the height of the smaller cone. So 50 over 10 is equals to 48 over x. So this will be 48 over 5. That will be 9.6. So height of the smaller cone is 9.6. To calculate the volume, we have the height, but we should have the radius as well. So I have to apply the same thing. That means 50 over 10 equals 14 over x. X is, in this case, x is what? I'm just calculating radius r, and let's say r2 and h2. This is h1. So this would be 14 over 5. That is 2.8. Now I have the radius and the vertical height of the bigger cone. So for bigger cone, I'm writing it here. Radius is, R1 is 14 centimeters and H1 is 48 centimeters. So volume of bigger cone will be 1 over 3 pi r squared h. So 1 over 3 pi r squared times h. That will give me 9847.04 centimeter cubed. Now I have to calculate volume of smaller cone. So we have calculated R2, that is the radius of the smaller cone, or this filled portion I can say. Radius we have calculated as 2.8, and or we can directly use, I just explained you the volume scale factor, either by that one or by formula. It's totally on you how you want to calculate. And H2 is 9.6. So this will be 1 over 3 pi r squared, which is 2.8 whole squared times h, that is 9.6. So we have the volume of the bigger cone and we have the volume of the smaller cone, the smaller portion which is filled with this liquid. So I have to subtract them simply. So I'm subtracting here 9847.04 minus 78.77, which will give me 9768.27 centimeter cubed. This is your final answer. Now see this question number 9. A tank in a shape of a cuboid is filled with water. The tank has dimension 54 times 77 times 8. When this water is poured in conical tank of slant height 75 meter and radius 21 meter, calculate the vertical height up to which this tank has been filled. So, this water is completely filling this cuboid. That means if I'll calculate the volume of this cuboid, I'll be able to calculate the volume of this water. So obviously, volume of cuboid is equals to volume of water. We know the volume of cuboid is length times width times height. So it would be 54 times 77 times 8. So from here we can calculate the volume of cuboid as 33880 meter cubed. And that is the volume of water. Now this volume of water has been filled in this conical tank. See, volume remains exactly the same. If it's 33880, then still when you will fill it here, the volume will remain same. But now the water has taken up the shape of the frustum. That means now the volume of water is equals to volume of this frustum. We know the volume of frustum is volume of bigger cone minus volume of smaller cone. This is equals to volume of frustum. So now we have to calculate volume of bigger cone. So volume of bigger cone is 1 over 3 pi r squared h. We don't have h here. We have to calculate. We know this is a right angle triangle. So 75 squared is equals to h squared plus 21 squared. H squared is 75 squared minus 21 squared. And finally, on solving, you'll get h as 72 meters. So this will be 1 over 3 and we have to take pi as 22 over 7 given in the question. So 22 over 7. R squared is 21 times 21 and h is 72. This would be equals to 34650. Now volume of frustum is 33880. Volume of bigger cone is 34650. And volume of smaller cone, we know that they are similar. So there is a factor called volume scale factor, which I just explained. So then volume of small cone times scale factor, volume scale factor is equals to volume of bigger cone. That means volume of small cone is volume of big cone divided by volume scale factor. Let's say volume scale factor be x. So volume of bigger cone is 34650 over x. Let's say x be volume scale factor. So 34650 divided by x will give you volume of smaller cone. So from here we can easily calculate a scale factor. So on solving, I'll move this on to the right hand side and I got negative 770 equals negative 34650. So x will be, that is your volume scale factor is negative 34650 over negative 770, which is 45. We got that the volume scale factor is 45. We know volume scale factor is what? L cubed. This is 45. That means length scale factor is cube root of 45. I'm taking approximately this as 3.6. Let's see, you'll get a decimal. I've just approximated. So 3.6 would be my length scale factor. So we know that actual height is 72 and we have to calculate this height. So that means we can calculate the height of the smaller by dividing it with the scale factor. So 72 divided by 3.6. will give you height of this one. This is smaller cone. But we have to calculate the volume of frustum. So this will be 20. If this part is 20, we'll calculate the total as, like the height of frustum, as 72 minus 20, which is 52. So this is how you can calculate, and you can solve questions on volume and surface area of the frustum. So yeah, that's it for today. We'll meet in the next class with volume of frustum of pyramids. So that's it for today. Bye. Take care.